Hello, everyone. My name is Dan Jonas Roach, and I am the news editor here at the Architects newspaper. I'd like to welcome you all to the Specifier's Guide to Frameless Glass Railing Solutions live webinar, a CE Strong webinar series powered by the Architects newspaper. This webinar is sponsored by Q Railing. This program is registered with the AIA CES for continuing professional education. Questions related to specific materials, methods, and services will be addressed at the conclusion of this presentation. This webinar is recorded and can be easily replayed when re-registered on the same webinar registration page. Please allow 7 business days to process certificate of participation and AIA credit reporting for this presentation. At the end of this course, participants will learn how to evaluate the substrate, application, and level of use to specify the appropriate mounting method for a secure glass railing system that meets IBC location, height, and loading requirements, compare monolithic tempered glass to laminated glass, and identify appropriate applications to meet IBC material and loading requirements. Describe the suitability of various metals and finishes for different applications and locations to minimize corrosion and deterioration. Implement handrail, cap rail, and lighting options that meet code and provide safety and aesthetic value to a project. Utilize case studies to recognize the role frameless glass railing systems play in solving design challenges with a minimalist aesthetic. We encourage you to ask questions using the Zoom Q&A button found at the bottom of your Zoom window. Now I'd like to introduce you to today's presenter, Charles. Charles is the Director of Marketing and former Director of Project Solutions for Q Railing, North America, with over 20 years experience in architecture and building products. During his tenure at AECOM, he became a lead accredited professional while working as a business development manager, technical designer, sustainable design lead, project manager, and a consultant for the City of Chicago Department of Construction Permits and Code Review. He has applied his architectural know-how over the past 10 years as a marketing manager for major brands within the solar and building product sectors. He brings a dynamic view to the architectural industry as a product advocate with a mission to help designers, builders, and contractors simplify the process of integrating building products into a project's design throughout the design, permit, and construction lifecycle. He has a bachelor degree in environmental design, architecture, and marketing from Ball State University. Remember to please leave your questions for Charles in the Q&A window. And without further ado, please welcome Charles.
Can you hear me now? Okay. First off, thank you for the introduction. Very much appreciated. Q Railing is very appreciative of Architects newspaper. Is very appreciative of Architects newspaper for providing such learning opportunities and allowing Q Railing to sponsor this event. As mentioned, today's presentation is the Specifier's Guide to Frameless Glass Railing Solutions. This will qualify for 1 CEU Learning Credit Unit. As mentioned briefly, just want to review again the overall purpose and learning objectives of this presentation in summary format. First thing we're going to do is talk about some of the components that actually comprise frameless glass railing systems. The next thing we're going to do is cover throughout the presentation the different codes that will apply to these systems and what you need to understand and consider when specifying such systems. We will also go into the different types of glass that are needed to incorporate into a frameless glass guardrail or balustrade. We will also cover the different types of materials and their advantages, as well as some of the accessory components that go along with them, including handrails, cap rails, and LED lighting. And lastly, we will end the presentation covering some case studies to show you some of the guardrails in action in previous projects that have been completed. As mentioned, we will be taking questions. We will be actually answering questions at increments throughout the presentation. So if you do have a question, go ahead and type it in the box, and we will address those questions as we move throughout the presentation. And just note that if we were not able to answer your question, we will make sure that the answer does get back to you in writing after the presentation commences. So first off, let's understand a little bit, why do we have glass railing systems? Well, ultimately, the main purpose of these elements are not really for architectural essence or design. They are there because we are providing an element of safety to the occupants of the building. That is the overall primary purpose of these elements that we will be talking about today. So one of the things that is very important with these elements is they need to be very high quality. They have to be made of materials that can stand the test of time. They have to be made with materials that have been tested, and they have to be made with materials that are able to resist the loads that the codes require upon them. The other thing that we want with these components is we want them to be able to integrate into the overall architectural design, as well as celebrate the architectural essence of what we're trying to do with that building, overall facade, elevation, or the space that the guardrails are incorporated into. Typically, we'll see these in balconies, roof decks, etc., at the edge of the buildings, where we want to make sure that we're allowing the view to extend beyond the building into the surrounding environment in which the building is located. So in essence, what we want to say is these want to celebrate views and panoramic views. And there's nothing better in the guardrail sector than the systems that are called glass balustrades, right? The other thing that we want them to do is be modular and interchangeable. What do I mean by that? What I mean is that they easily integrate into the building. They work on a very repeating grid if needed, and they're very easy to incorporate into the design. What we don't want are what most manufacturers try to achieve, especially with the glass railing balustrades, is that they don't dictate the architectural design to change for them to be incorporated into it. They seamlessly incorporate into a design that has already been established. And that is one of the major things that we'll see about glass balustrades here. So what are the different components and systems that we will see throughout this presentation? And we're going to talk a little bit more in detail. So the primary systems that we'll see in the market that are defined as glass railing systems are comprised of base shoes, base clamps, and adapters. Those systems can be installed in a variety of ways as they interact with the building. They can either be top mounted, they can be fascia mounted, they could be recessed in the floor. We will typically see them made out of two major materials in the market, metals specifically, either aluminum or stainless steel, and we'll talk about the advantages and disadvantages of those later in the presentation. And then another thing that we'll see along with these systems is we'll see some accessory components like edge protection, cap rails, handrails, and LED lighting. One of the major advantages of a glass rail system is the ease of installation. We're overviewing the amount of components that are in this system. In reality, we really have the guardrail component, the glass, and any accessory components. We have very few components. So these are really easy to install. And so that is something to take in consideration as well when you're looking at the total project cost of incorporating a specific guardrail system. So now let's talk code. When are these required? When are we need to put one of these into a structure? Commercially speaking, in short, when we have a rise from grade greater than 30 inches, we need a guardrail. We need that, whether it be a ramp that raises 30 inches from grade, whether it be a balcony, any type of structure that's associated with an architectural design. Such guardrails then need to be 42 inches in height, and we'll talk about what all needs to be incorporated into those guardrails as we move throughout the presentation. Now, guardrails are incorporated into a large variety of different types of projects. It could be commercial, it could be residential, it could be light commercial, it could be multi-use, it could be a high-rise, it could be a multi-residential building. And what we like to say is we have interior and exterior, but then when we move to exterior, we have systems that need to meet high or heavy load requirements. And when we're talking about heavy load requirements, we're referring to guardrails that may be in hurricane areas where they have to resist design pressures anywhere over 200 pounds. And we'll talk a little bit about more specifics as we move throughout here. So the first part of the system that we need to take in consideration and really comes into play very early on in the design process is, what is the substrate that we're going to be connecting the guardrail to? The most common that we will see in the industry, and let's speak this in commercial terms, is concrete. Typically, most concrete out there, the minimum specification that we will see in today's market is about 4,000 PSI. Now, if we're looking at some historical buildings, we will see some concretes that's 3,000 PSI, even down to 2,500. We do need to be cognizant of that because that is something that will impact the overall design of the guardrail. Most specifically, when we talk about substrate and we talk about a guardrail, we are talking about the anchor, which is going to fasten the guardrail component to the building, to the substrate. Things we need to consider with concrete that are critical. We need to consider the edge distance. And what do I mean by edge distance? It's from the edge of the slab to where the anchor is located, typically with concrete, to use what we call industry standard mechanical anchors. We will need about 4 inches. When we have a typical guardrail load with a base shoe, we will need to have an embed somewhere around 3.5 to 4 inches into the concrete. So we will need a concrete depth that's anywhere from 6 to 8 inches in that instance. When we do start talking about base clamps and adapters, one of the things that we do have with those is the anchoring is not as often. So then we will see a larger load transfer to the anchor itself. And we will have an embed that will be needed of anywhere from 5 to 6 inches into the concrete with an anchor that is for a base shoe. Or if we're going fascia mount with an adapter that we'll talk about later, we're going to need somewhere between 5 and 6 inches embed. The other thing we need to take in consideration about the concrete is its overall strength. The strength of 4,000 PSI is a standard. That's what I just talked about from an embed standpoint. But if you start getting stronger PSI concrete, 5,000, 6,000, which we'll typically see in larger commercial buildings, as we move up to high rises, we can see things that values that get up to 10,000, 12,000 PSI. That will reduce your overall embed required for your anchor and could also possibly reduce your required edge distance. Now, one of the things that we do like to do in the market is we like to get the guardrail as close to the edge as possible. What we can do in concrete is we could use something called a two-part anchor, or typically referred to as a chemical anchor, that will allow us to get that edge distance all the way up to about 2.5 inches. Then we move on to steel. Steel we will typically see in two formats. We'll see it as an embed into the concrete, so it will be like a steel plate. Welded to the bottom of the steel plate, we'll see an element called a Nelson stud. The Nelson stud will then get laid down in and will be poured and put in place when the concrete is poured. And then you can ultimately just attach the guardrail to the steel itself. And when we start attaching to steel, what we want to see from a thickness standpoint is we want to see anywhere from 3/8 to 1/2 inch. If we start getting to really heavy loads, we may go to 5/8, but not typical. And we'll see anchors that are M10 or M12. M12 is the metric conversion to about a 1/2 inch diameter anchor. And then what we will see is we will also see in steel that we have some type of steel angle that is where the vertical leg is attached to the building structure, and the horizontal leg is what will go ahead and carry the overall guardrail element. So those are the different attachments to the substrates that we will see in these type of systems. Another thing that we will see is wood. I would say this is more residentially focused. Wood is one of the most challenging to attach to because it requires an extreme embed depth with wood, because we need to use some type of anchor like a GRK or a structurally rated screw that will go into there. And typically what we'll see in a guardrail, and we'll talk about this as we move into base shoes and adapters and so forth. With a base shoe, for example, which is attached every 8 inches at 42 inches high, we will see a transfer load that is somewhere around 2 to 3 kips or 2 to 3,000 pounds per anchor. So when we get into a situation where we're fastening into wood, a typical GRK screw that's about 4 inches, that's fully embedded, will have a withdraw or moment resistance of about 1,000. So then we need to do one of two things. We need to either start moving the lag bolts at a 1/2 inch diameter, and we need to start increasing the embed depth down to about 8 inches. So what we need to be cognizant of is when we do wood, we either need to have like a steel angle behind it, where we can fasten through it into the steel angle, or what we need to take in consideration is we need to offer wood blocking, where we're going to have attachment points for guardrails when we're using a wood substrate. So let's kind of, in summary, some of the other things that we want to understand and really think about when we're specifying guardrails is, can the substrate take the loads? We really just talked about that. Some of the things that you need to consider, right? What is the interface between the finished floor and the railing, right? How are you going to attach those? Is it interior, exterior? Down to the 4th bullet point, if it's exterior, how are we going to consider the waterproofing? Who's responsible for the waterproofing detail, right? Then the other thing that I want to highlight is when you think about this, typically we are fastening guardrails to the raw substrate itself, and then we're going to butt up a finished floor to the element. So we have to be very cognizant that the code requires 42 inches net from the AFF or the finished floor. So if we're fastening it down to the raw substrate, and we have a finished floor that's somewhere from 1/2 inch all the way up to 1 inch, we need to make sure that we specify that system as 43 inches total in height, right? So you have to be able to take that into consideration. So different mounting types. So this is going into the different systems that we have. As I mentioned, base shoe, base clamps, and adapters. Let's just go ahead and dive into each one of those. First is we have base shoes. You will see in the market from almost all manufacturers, they will have base shoes, which we call from small to large, light use to heavy use application base shoes. They will have base shoes that have the ability to take on some curving if needed for a curved glass guardrail, right? They can incorporate monolithic or laminated. However, typically in code, when we have a guardrail situation, we will need to use laminated glass, which we'll talk about in more detail. And then, as I said, there are varieties out there to take hurricane impact type winds that are there. The other thing that we also want to talk about is there are many ways to fasten the glass into a base shoe. The first of them is a wet set system, which is using some type of structural caulking. The next is a dry fix system, which could either use some type of wedge, or it could also use a disc or a taper lock, some of the common terminology out there in the market. And they're suitable for all varieties of applications: interior, exterior, residential, mezzanines, roof decks, etc. Base shoes really are the quintessential glass railing element that we see in the market. They can be top mounted, as you see in the diagram here. They can also be fascia mounted, which means they would be installed to the face of the building. There are some challenges with fascia mount. You would then need access to the exterior of the building from the outside to fasten that element into the building itself. But one of the things that is nice with at least some of the industry systems is they do allow for the glass installation to take place from the interior side of the building. So then when you're doing the heavy lifting, you are not required to have some type of crane or whatever to lift that glass into place if you are dealing with some type of high-rise application. Another advantage that we'll see with fascia mount is it will allow the element to become part of the facade lower down. And when the occupant is looking from the space that they occupy, they actually don't see any of the guardrail elements in their view, and provides the cleanest, most celebrated panoramic view possible for this type of application. Now, as I mentioned earlier in the presentations, one of our goals is to always move that guardrail to the edge of the building as possible, but we have to move that anchor a little bit away because we have to meet our edge distance requirement. So as you see here, we have a profile that you will see in the market, which is called an F-type profile, which allows us to accomplish kill two birds in one stone, move the glass as close to the edge as possible, and get our anchor away enough so that we can have our edge distance. We will also see F profiles used if we have larger design pressures on the overall system itself. Similarly, as we have F profile for top mount, we have Y profile for fascia mount. Now, one of the nice things that we can see that is possible with the fascia mount is if we do have really high loads, we can move that Y profile down, show the anchor that we have there, and also put an anchor where you may typically see it if it was a typical fascia mount, and have a double anchoring combination. The other thing to understand from a loading perspective, when we are talking about design loading engineering of a top mount versus a fascia mount system, a fascia mount system will have slightly better design resistance values than a top mount system. So the next type of system that we'll see in the market for glass balustrades is base clamps. Similarly to base shoes, it is a cantilevered glass system. However, a base shoe is a continuously supported cantilevered glass system, whereas a base clamp is a point-loaded cantilevered glass guardrail system. Now, what does that mean for us? It means a few things in the design stage. Typically, you will see a lot of prescriptive engineering out there for base shoe systems because we do have predictability in the performance of the shoe leg resistance and the glass itself. So you are most likely able to prescriptively design and engineer a base shoe system. When we use base clamps, we will have to start integrating a finite element analysis into the equation because we're going to get some type of V stress pattern on the glass. And really, it's going to come down to designing the glass into the base clamp to make sure it can work. Now, with the other thing that we will see is base shoe systems can start anywhere from 9/16 thick and move all the way up to 1 1/4 inches thick in the glass thickness. Base clamp systems will take thicker glass for them to achieve the same type of performance as we did with a base shoe. So you'll start with like 27-30 seconds when you actually have a guardrail system with a base clamp, okay? But one of the things in the market that we will see base clamps used for quite often is a pool barrier where it's on the first level, then it does not have guardrail requirements, it is only a glass barrier requirement, but then it is something where you're allowed to put it on your patio. You create resistance from any young individuals getting into the pool itself, and you have those gate requirements, and then you don't have guardrail requirements. And so that's when we will commonly see base clamps used. They're more used in lighter use cases. Interior residential is typically when we will see them, or exterior when they are used as glass barriers. Then the last of the system types that we have is adapters or standoffs. Okay, so base shoes have a variety of mounting ways. Base clamps are always top mounted, and adapters and standoffs are always fascia mounted. We can see adapters in a variety of types and shapes. We can see them circular, we can see them in square. Really what they are, we will most likely always see them as pairs, stacked pairs. And the reason why is, again, we're going to see adapters that are spaced anywhere from 12, 16, 14 inches apart. And so therefore, we're basically doubling the load that we would have on a common base shoe anchoring standpoint. So that is the other thing. The other thing we also see is we do need to handle the overall stresses that are handling on the glass. Similar to a base clamp, this is a point loaded cantilevered glass system. And again, you will be required most likely to do an FEA. You might have some past projects that will point you in the direction that you need to be in, but in overall, to get your overall performance on the system and understand it for a project basis, you will most likely have to run an FEA for that project. So the other thing that we can see in the market is what we call combined standoffs, which we then call adapters. We commonly call them in the industry telephone adapters. And one of the major advantages of those is that they will have a single attachment to the building. But then again, keep in mind, it's going to carry all of the load. So it will be a larger anchor into the building, but it will allow to provide some relief to the overall stress connections to the glass itself. Lastly, what we'll see is what we commonly refer to as a Juliet balcony element, which is just really a continuous channel that can mount the glass from jamb to jamb. We'll typically see them in doors or windows. This is more of a common application that we would see more in Europe than we would see more in the States. So in summary, let's kind of talk about the systems we talked about. So we talked about base shoes. We talked about base clamps. We talked about adapters, standoffs, and then quickly we talked about Juliet balconies. As you see there, base shoes are really good for all applications. Base clamps are really limited to light use or glass barriers, and they're always top mounted. And then adapters can move into the light use, into maybe light commercial use as well, and they will always be fascia mounted in summary. So I'm going to ask a question, just kind of answer it to yourself, and then we'll actually take some of the questions that have come into the chat. So what options are available when mounting with a base shoe? So the options are, you could top mount it, you could fascia mount it, you could do it in floor. We didn't talk about that in detail. And the other options is you could top mount it with an F profile or fascia mount it with a Y profile. So at this time, I would like to turn it over to Angela and see if we have any questions at this time.
Hi, Charles. No questions at this time, but I do want to say as a reminder that you could ask questions with the Q&A option down below your screen.
Perfect. Thank you, Angela. Well, with no questions, we'll go on and we'll move into glass, and we'll talk about glass in detail here. So first of all, when we do have guardrails, we do have to incorporate safety glass. Now, the safety glass itself will be tested by the plate glass manufacturer. Those are the manufacturers out there in the market that manufacture the single piece of plate glass. When we are talking guardrails, we will introduce into the market or into the chain of supply what we call a glass fabricator. And that fabricator is going to transform that plate glass into the safety glass that we need to incorporate into guardrails. So let's talk a little bit about the requirements and the minimum requirements of what we need in glass. The first of those is the glass needs to be a minimum of a 1/4 inch thick. And that is a 1/4 inch thick when it is incorporated into a laminated piece of glass. I don't think we would ever see a 1/4 inch thick work even for a glass barrier. It's going to meet a certain set of testing requirements, ANSI Z971. Again, this will be handled by the plate glass manufacturer themselves. But let's talk a little bit more about what are the loads that we as designers need to be taking into consideration and engineers when we're speccing into the project. So the first thing we need to do at the top of the guardrail itself, the guardrail has to be able to resist 50 pounds per linear foot. The next thing that that guardrail needs to take in consideration is it has to be able to resist a concentrated point load of 200 pounds. Okay. The next thing we need to also take in consideration when we do have a glass guardrail, the glass is the infill. The glass itself needs to be able to resist 50 pounds on an area no greater than 12 inches by 12 inches. So basically 50 pounds per square foot needs to be able to be resisted on the glass infill itself. Those are the testing and the load requirements using the IBC as the baseline for this. So we have different types of glass in the market. The first type of glass that we have in the market is plate glass, and typically that will be called annealed glass. Then the next thing we have is we call it tempered monolithic glass. So that is basically taking annealed glass, and what we are doing is we're putting it through a process. We're tempering it. We're bringing those molecules as tight together as possible, and we're making them as strong as possible. Then what we do, the next process that we would do is we would take those tempered monolithic pieces, we would laminate those together with an inner layer, and we would create tempered monolithic laminated glass, which is typically what we will see in the market for guardrails, commercially speaking. Things to keep in mind: a piece of tempered glass is 5 times stronger than annealed. Another type of glass or strengthening process that you will see in the market, not so common, not as good as tempered, is you will see heat strengthened glass, also commonly referred to, and is acceptable by the codes that are out there in today. The other thing we also need to take in consideration is that guardrails may break sometime. And what we want to make sure of is when they do break, they do not become a cutting hazard. So when we go through the tempering process on a piece of glass, that piece of glass then turns into pebble-like pieces when it breaks. It does not look like the knife shards that we would see if we break our glass mirror in our bathroom, which is annealed glass. So that is something that's important. The other thing is when we do break a piece of laminated glass, when we have an event, it would not be atypical to have one side of the glass break and the other side stay intact, where it is also providing additional security for the occupants, even when we had an instance of failure. So laminated glass can be anywhere from, I would say, 9/16 to 1.25 inches. We use inner layers. It is quite strong in nature. We do use inner layers that are commonly called in the market that we see for guardrails is PVB and SGP. Now, polyvinyl butyrol, okay, can come in thicknesses of 0.03 and 0.06. There will be equivalents in the market that we will hear that are EVA. Now, one of the things that I need to strongly caution you as somebody who has been involved in the design and engineering of hundreds of guardrail projects, is that PVB and EVA will not calc out at a typical 42-inch high guardrail. They will make it at about 36 inches at a 0.06 for a typical PVB. Now, there is structural PVB in there in the market that can get there, but a typical PVB or EVA will not work for a typical 42-inch guardrail. What we will want to see and use in the market, and as a standard, what we should use is an SGP interlayer, which is commonly referred to as ionoplast. SGP is the Kleenex reference to ionoplast by an actual manufacturer out in the market. We will actually see that in thicknesses of 0.06 and 0.09. Ironically, the material comes in thicknesses of 0.03 and 0.035. And what we will do is we will build those up to 3 different layers to get the thickness that we need for the actual project. The other thing that we also need to be cognizant of when we're speccing a project is how clear do we want the glass to be? And the ironic thing is clear glass, commonly referred to in the market, is a little bit bluish or gives off some greenish tint. So we need to understand that. If we are looking for the clearest, most transparent looking glass possible in the market, we are going to specify something called low iron glass or extra clear glass. So you need to be cognizant of that in the market. So the other thing that we also have to be concerned about is we have that element that fastens to the building at the substrate, which is the base shoe, the base clamp, or the adapter, right? Then we have the glass that goes into those elements. Then we also, by code, are commonly need a top cap onto that system. And that top cap provides a few benefits. And we'll talk about that as we move through on later in the presentation. But from a code perspective, they want the top cap because it provides some loading benefit to the system. But if your system has been tested or has a industry accepted report, like an ICC report, where it has been tested without a top cap, then you are not required to have a top cap. And that testing standard that needed to be tested to is dictated and is written by ASTM 2353. We will also use this standard if we want to take the overall allowable deflection in the engineering of a system beyond 3/4 of an inch to an inch. We can sometimes get away with a 2 inches plus in an overall guardrail if we have some testing that verifies it has taken its impact, the glass has deflected, the glass has come back, and it has returned intact, and it has not broken in any way. Then we can allow that standard to pass for a project and be incorporated into a project. The other thing we also have to be cognizant of is that we're allowed to have allowable deflection design standard. We would like to see 1/2 to 3/4, no more than an inch as a standard. Is that 9/16 inch glass will deflect more than the glass thickness itself under its allowable deflection. And what that means is basically the glass will deflect. It will create an opening in that glass, which then if my hand was in there, could create a pinch hazard. So when we always have a system with 9/16 glass, because of the pinch hazard, we do need a top rail. It's at 11/16 and higher that we will typically see systems without a top rail specified. So a review question here. What are some of the differences between tempered and laminated glass? Well, pause for a second and answer that to yourself. So the answer is it's not really a difference. It's one is incorporated into the other, really, when we have a guardrail system. Tempering is tempering of the plate glass itself to strengthen the overall plate glass. And then laminating is taking that tempered plate glass, bringing it together with an inner layer, and creating an overall really strong glass assembly. At this time, I'm going to turn it over to Angela. Angela, do we have any questions in the audience?
Hi, Charles. Yes, a few questions here. So, can your specify pre-engineered glass railing systems law 2022 CBC?
I'm going to have to get back to you on that specifically in writing. I don't know exactly what you're referring to. If there was a more generality of what you're asking me to have it comply to, let me know.
Can you discuss exterior balcony or deck drainage with the various base shoes and adapter configurations? Can the glass rail shoes include drainage, or is the drainage handheld by other trades?
Okay, so this is a very good question. Thank you very much for asking that. So, with a base shoe system and a base clamp system, there is some passive water drainage or weeping out of our elements or typical elements in the market so that the water can get out. Okay, but that is only passive. That is passive of getting it out of the overall guardrail system itself. There are elements that are offered by manufacturers that create an overall active drainage system, i.e., getting the water off of the balcony to the exterior of the building to an overall weeping system to get that away and gutter out. You can use a variety of things. You could use drainage blocks to overall lift up a base shoe or a base clamp. You could use a drainage profile, which is typically run every 24 inches, and then you put like an 8-inch gap so that you have an overall active space where it can you have active water exiting from the system itself. So yes, there are elements that are done, and railing and guardrail manufacturers can help you solve those issues.
Glass rail system at base of bleachers. Should the guardrail height be higher due to how one may trip forward?
I this is a tricky question, because ultimately you could say somebody could be standing on the seat, right? And there are certain requirements specific to stadiums themselves for additional strength in the guardrail, because there are additional loads that are put on and are maintained onto the system for people leaning over. As far as heights, we have not seen typical higher heights required in that type of application, though.
How is the strength of the glass according to the region? High humidity and hurricane zones, for example.
Okay, so the strength of the glass that we will typically see in a hurricane region, we will start with 1-inch glass and move up to 1 1/4. You will have a base shoe that has some type of girth that's sitting around 3 3/4 inch wide by about 5 1/2 inches tall, and it's a pretty substantial looking base shoe. But in reality, it's pretty transparent to the alternative of trying to solve that solution with a overall post and rail type of application.
Pre-engineered glass railing systems with ICC reports.
Yes, you will see them. Ourselves does have them, as well as a lot of other manufacturers will have them. They prescriptively allow you to understand what base shoe element or adapter or standoff element. Again, you will see commonly that base shoes are what you will see in the market most commonly with an ICC report, and you can prescriptively engineer from there, as well as use that to get through some of your more simpler permit processes. As we move to larger projects, we will always see manufacturers prepare shop drawings and get a specific stamp to the guardrail system itself.
How do you deal with roof element if using fascia mount on the parapet wall?
So the answer is, when we start putting a base shoe, either fascia or top mount, onto a parapet wall, we will have a wind velocity factor that we will have to increase under ASCE, because there's multiple factors that we have to take in play. So the first of those factors being is we have the overall wind, right? Typically anywhere from 90 to 180 to 200 in hurricane. Then we have the overall installation above grade, which is from 0 to however how high it goes. Then we have the overall exposure category, which is dealing anywhere from zone B, C, or D, right? Those are all the things we need to take in consideration. Then we do have a wind velocity or pressure category. When we have a balcony that is covered, we only have to take in consideration the pressure from the outside. When we have a balcony, a guardrail system that is on the top of a parapet or uncovered, we have to take in consideration the positive and negative pressures in combination. So in essence, your system will get more robust, your anchors will get deeper, and you will have a lot of impacts by doing that, mounting it onto a parapet. At this time, Angela, what I'm going to do is continue on. I'll probably speed through the case studies so that we can answer a few more questions, but I do want to get into materials and kind of the supplemental components, okay? So let's talk about materials, right? So I said earlier, most materials we'll see in guardrail systems, glass guard, are aluminum and stainless steel. We will have some zinc components. Those you could see in some of the hardware, something if we were using it in an interior application. But we also have to take in consideration what's the environment that we're putting these things into. Are we in an interior? Are we in an interior where we don't have any contaminants, pollution from a factory? Are we near an ocean with saltwater contaminants, etc.? Those are all the things that are going to input our overall material selection for the system. So we will commonly see stainless steel and aluminum. Stainless steel, we will see grade 304 for interior. We will see grade 316 stainless steel for exterior. We will see aluminum in mill finish for interior and aluminum with anodization for exterior. And those are the things that kind of help us out, are the different grade of the stainless steel, as well as anodizing the system when we have aluminum on the exterior. The other thing that we have to take in consideration and always communicate to our clients is that systems do require operation and maintenance, i.e. cleaning. We must clean metals. And I'm going to explain in the next slide why. But here are some of the things that we can see. You'll see pitting on anodized aluminum, and you'll see T-staining on stainless steel. It's even more important in a guardrail because you want to give people the sense of security when they go into that space. And sometimes when they look degraded like this, they just may not feel safe, even though they may be performing to the level that they should from a structural performance standpoint. We have corrosion. Corrosion will happen. The key is we need to minimize and control that corrosion. We want to create passive oxidization to create a layer of protectant onto that material. We do that through the process of bringing the material into service by one of my favorite tongue twisters, pickling and passivation. So pickling is actually the removal of the layer of the stainless steel, and then passivation is cleaning off the contaminants and then providing a slight passive layer of oxidization to help resist the contaminants from getting back onto the metals. But the thing is, once it happens, we can bring it back to life, passivating it, right? So passivating it is we're putting some type of cleaner on there. We're allowing it to sit. We're allowing it to break through those contaminants. We would use some type of slightly abrasive cloth, very important in the direction of grain. And we can bring it back to life. As you see in the picture here, in the top and the bottom, we have brought something back to life as good as new just by going on and cleaning it and passivating it. Now, we need to think about the material finishes that we select in these instances, okay? We have many finishes that these can be in. They can be in satin. They can be in brushed. They can be in mirror polish. They can have powder coating. They can have wet painting. When we have an area where we have contaminants, we're going to want a mirror polish because there are no crevices. We're going to want a powder coating, or we're going to want a wet paint that has a high resistance to the environmental environmental impact, right? So those are things we need to take in consideration when we are specifying materials. The other thing that we have in glass guardrail systems is the overall accessory components, one of them being handrails that we will most commonly see in stairs and ramps, right? Such guardrails need to be mounted at between 34 and 38. We typically design at a standard of 36. And then that allows, when we have some of those varying runs where we need to get down to the landings, we can land in between that 38 and ensure that we stay within the code, right? The other thing that we can also see is we can see a variety of shapes. It is acceptable to have a circular or a rectangular or a square. There is just a perimeter requirement that you have based on your code, the max perimeter or the max diameter all the way around that overall element. The other thing is handrails can be post mounted, can be glass mounted, can be wall mounted. But one of the things I want to caution you with is when we do have a handrail, and we do have a handrail that terminates at the bottom of the stair or the top of the stair, we have two requirements. We have the building code requirements, and then we have the accessibility requirements. The building code requirements require the guardrail to pass the bottom of the stair by 1 tread depth. The top we are required to pass by 12 inches. But we also have the accessibility requirement that requires us to return the handrail in one of 3 ways. We need to bring it down 12 inches and then bring it back to a post or to the guardrail itself. We need to return it all the way down to the floor, or we need to return it to the wall. So this is where the building code has one set of requirements, and then the accessibility code adds on additional requirements in design that we need to take into consideration. So just understand that when you are designing these types of systems. Handrail brackets could be mounted through the holes on the glass, through holes in the glass, or they could be mounted in the expansion joints that we have in the glass, but something to take into consideration. When we do specify them with holes in the glass, those holes need to be done during the glass fabrication process prior to even tempering the monolithic glass. Once we temper glass, we cannot work the glass in the field. It is no longer workable once it has been tempered. So you do need to take that into consideration. The other accessory elements that we will see is cap rails. Cap rails provide some function. They also provide some aesthetic to the overall system itself. They can be commonly mounted with some type of gasket that you see here on this slide. They can also come in a variety of materials and shapes. They can be circular, they can be rectangular, they can be aluminum, they can be stainless steel, they can be wood. They are commonly referred to in, I would say, 3 different categories. One is edge protection that just protects the top of the glass itself. And so when we get edge protection, some of the things we need to take in consideration with glass. One of the easiest places to break a piece of tempered glass, which, as I have mentioned in the presentation, is a glass where the molecules have been pushed together so tight that it's like a rubber band, are at the corners of the glass and the top edge of the glass. So we want to maybe protect the top edge of the glass. The other thing that we also need to take in consideration when we're talking about ASTM and ANSI standards for the production of laminated glass, putting those 2 pieces of laminated glass on a common 48 by 48 inch piece of glass, the common slippage allowed by standard is 1/8 of an inch. So you need to take that in consideration as well. The other thing we'll see is something called a U profile, which is more of just a common U, really not a shape, but is kind of an in-betweener between an edge protection and a cap rail. A U profile typically can count for structural benefit in engineering, and edge protection cannot. And then the major advantage of something with a cap rail is it typically comes in shapes, different shapes and sizes, and can also include LED lighting. You can incorporate lighting into your cap rail or your handrail for that matter. And one of the things that's nice in these type of systems that are integrated into the guardrail is all of the wiring is incorporated into the system too. You'll see it going through the actual saddles. You'll see it going through the cap rail and the handrail. And then those will drive to the overall home run of the system and to the transformer. And then that transformer will then go on to the electrical system so that you have all of it integrated. And then that is very nice and seamless and honestly looks really slick. And the other main advantage of LED lighting is it provides additional guidance and lighting at nighttime when people are typically in an area where they have travel or they're in an area where they're celebrating the space, right? So let's kind of talk about what are some of the advantages of cap rails. And I didn't really talk about this one, but the other one that I would like to say is, as designers, one of the things that you need to take in consideration is we want to design a perfect system, and we want a system without a cap rail, obviously, because it looks the most transparent as possible. But the other thing that we also have to take into consideration is that when these buildings are built, the substrates are not perfect. The leveling of the system is not perfect. And then we come into the area of trying to align the glass itself. And this is where I think an edge protection does two things. It covers the top edge and it helps with glass alignment. Now, there are systems out there like our system or a system with a Q-disc or a taper lock that would allow you a little bit of glass planing to help do that. But another, what I would say, an active element in the industry to help with glass alignment on the system is actually a cap rail. That is what I would say is one of the major advantages, in addition to providing some architectural or geometric kind of architectural essence to the system itself. So at this time, before we go to case studies, Angela, why don't we just take 2 or 3 questions, and then we'll make sure that we answer any of those other questions in writing and they get distributed to the participants.
Do you provide support during fabrication if the project is outside the US?
Yes, in this instance, because we are a global company, there are people that will provide that. Yes, the answer is yes.
Can you obtain pre-engineered glass railing systems in the market, i.e. standard sizes, spacing?
In essence, that would be utilizing an ICC report and taking the elements off the shelf and the glass from the market. Yes, basically it's taking a prescriptively engineered system to accomplish that. Ourselves and some other manufacturers out there have their elements in stock, and you could put a system in play in anywhere from 2 to 3 weeks. Typically, the long lead time in that pull is going to be the fabrication of the glass.
Okay.
Any other questions?
Can you distribute your PowerPoint?
Yes, we could do that.
Last question. For exterior installations, are there thermal isolation methods that should be considered for metal and glass connections?
Okay, so from a thermal isolation standpoint, you are going to get expansion and contraction in the system. Unless you're in extreme freezing areas, heat's not as much of an issue. Extreme freezing areas, you may have to have some type of thermal break into it. But one of the things that we do incorporate into designs that you will see most commonly with a glass rail system is we will put a expansion joint into the system itself to allow for some movement of the system.
Okay, we're good.
Okay, so what I'm going to go ahead and do and respect everyone's time here is case studies we'll distribute. You can look at that. What I want to do is just kind of talk about an overall summary of the advantages of the system here. So we have glass railing systems. Really, they are the quintessential railing when we talk guardrails, when we're talking architectural essence and trying to celebrate panoramic views. This is what we're dealing with. Typically, base shoes are going to be the major component element that we'll see with that. Again, they're very simple in nature. They're very modular in nature. They're very easy to install. We did not talk about post and rail systems, but as I said, we reviewed this. We have the base shoe. We have the glass. We have basically the gaskets that hold it and the wedges or the Q-disc that holds in the glass. And then we have a cap rail, very simple in nature. We start talking about a post and rail system. We have a flange, we have a post, we have 4 anchors at every post. We have glass clamps, we have a saddle, we have a top rail. We have much more components. Our precision must be much greater when we are ordering our glass because they got to fall right into those glass clamps, where our precision can be a little bit less when using a base shoe. So those are things to take in consideration. The other thing that I would like to say, and is something that people may not realize in the market, is that base shoes are actually the system component that will best meet an overall hurricane type environment than using a post and rail. And the reason why is when you get into a post and rail situation, you're getting a transfer load where you're transferring anywhere up to 10 to 12 kips of load onto the post itself. When you have a hurricane load, which your substrate is going to be very challenged to do, where when you have a base shoe, you're spreading those out every 8 inches, and it's much easier to achieve the anchoring when we're talking about design pressures over 200 pounds, 200 pounds design pressure. The other thing that I do want to touch on just real quick that I didn't talk about in the glass is as glass gets wider, it actually does not get weaker in a glass railing system. The fallacy is when it gets smaller, what we do is we create a slenderness ratio in the glass, and the glass will have a tendency to want to break. So you need to look at a standard when you're dealing with 9/16 laminated of 36 inches minimum wide. And then as you move on to 11/16 and 27/32, you can start getting 30 and 28 inches. And when you move to 1 inch, you possibly can get to 2 feet. So thank you very much. Appreciate it. And at this time, I will turn it back over.
Thanks, Charles. I'm just going to give some closing words. Thank you all so much for attending the live webinar, The Specifier's Guide to Frameless Glass Railing Solutions, a CE Strong webinar series powered by the Architect's Newspaper. This presentation was sponsored by Q Railing. This webinar is recorded and can be easily replayed using the same registration link. Please allow 7 business days to process certificates of participation and AIA credit reporting for this presentation. A big thank you again to our presenter Charles and to Q Railing for sponsoring this webinar. We hope to see you all again at a future event. Have a great day.